Are you guys okay? Is it hot here?
No.
No, right?
Yeah.
If you feel hot, I'll turn on the AC, okay? Alright. So be comfortable, beta. Put your bags comfortably and then we'll start. Where did daddy go?
He's in the car.
He's in the car. Alright. Okay. So let's do a quick roll call. We have Ved, Mandeep, Kian, Aditi, Ahana, Shyanvi, and Soita. Soita, what happened to your camera? Shyanvi said her camera is not working. Okay, yeah, that's better. So what are we going to learn today? What did we learn yesterday? Do you guys remember?
Converting fractions.
And fractions to decimals. Yeah? Okay. Now, what we want to do is, we want to deal with little more operations related to fractions and decimals. Okay? And see what happens. If I say, did we do fractions to fraction multiplication division in the previous classes? Nahita, do you remember?
I think so.
We did? Okay. That's okay. Math is all about revising things and being as familiar as we can. So that way. So here's the thing. If I say add 1.03915 to 1.2. Who all can add it real quick for me? Does it look easy or look scary? Little scary?
No.
No?
I think I can do it.
Do it. I love seeing it on the piece of paper. So I'm asking you guys to do a simple decimal addition, okay? 1.03, okay, let me make it little easy for you guys, okay? Let me not scare you with the first problem. I'm saying add 1.03 and 1.2.
Still I have the answer.
I got the answer. I'm done.
How much is that?
2 and 2300.
2 and
2300.
22300 like this.
Yes.
Okay, yeah, let's see. What is the answer?
I got 2 and 2300.
2 and 2300. Same. Show me, what did you do?
I did the last
Okay. Okay. Let's see what Anayaka did.
Sir?
Okay, yep.
Do we have to do addition?
Yep. I have put a plus here. Let me make the plus look prominent enough. 1.03 plus 1.2. So, okay. Let me wait. Are you able to do it, beta? You got the same answer?
Sir, can I have a pencil?
Yes.
I was on
What is the answer, beta? 2.23. Wait, I could not hear you. Say that one more time. You're talking to the mute button. I cannot hear you.
Sorry. My answer is 2.23.
2.23. Okay. What is the answer, Sohita?
My answer is 2.23.
Okay. Yardi?
2.05.
2.05? Okay. Yaditi, what is the answer?
2.23.
Okay. Alright. Now, let me tell you guys. So, 2/300, that is one answer. I'm not denying that. But for now, I'll keep it simple. See, whenever you have a problem like this, I don't give answer to you guys, right? I always emphasize on making sure that you get the process right. So this is the process. Here, look at this one. Read this question first. Okay, 1.03 and 1.2. What is the difference that we see here? Shandy, hands down, but I'm explaining things. I'll come back to you if you have questions. Here between these two, what is that I see? I want to only be concerned about this part, whatever I have after the decimal. Here after decimal I have 2 digits, here after decimal I have 1 digit. Yeah? After decimal I have 2 digits, after decimal I have 1 digit. Do I deal with apples and bananas together? No. Apples in one basket, banana in another basket, oranges in third basket. Here, it looks like apples and banana to me. If this is apple, because it has 2 digits after decimal, this is banana or maybe watermelon. It has only 1 digit after the decimal. Okay? I want to make them similar. Now, what we know is 1.2 is same as 1.20. I can put as many zeros I want.
Same value.
Yeah. So don't worry about the answer because your teacher doesn't care about the answer. Yeah. Alright, so look at this. This is apple, this is banana. I want to, if I have a magic wand, I would want to convert apple and bananas into one fruit. Okay. So here I have 2 digits. I'll put a 0 here. I have 2 digits here also. Now see the magic. This was apple, became banana now. Same. It's easy now. Now look at this. I will write it very neat and clean. Okay. Now you add it. Here you have 3 digits, here you have 3 digits. Okay. It's like adding simple numbers. 3 plus 0, 3, 0 plus 2, 2, decimal remains in its place, 1 plus 1, 2. This is what everybody got, right?
Yes, sir.
I was just doing what? Adding some method to the madness. That's it. Is it making sense? Now, why I am saying so? See, this process will help you make sure that any decimal addition or subtraction, if you have to add this, what happens is sometimes 1.2 and 1.20 are same. If you have a decimal, you have the luxury of adding as many zeros you want, the value doesn't change. Similarly, if you want to add 0 in the beginning, nobody can stop us. If I enjoy drawing zeros, I can draw 5,000 zeros before that and nothing changes. Okay?
Like your marker ink.
I'm sorry,
Your
Rita?
marker ink.
I'm marketing.
Your marker ink will run out.
My marker ink will run out, but it's okay. I mean, I have enough markers for now. I will not worry about it. But what I'm saying is, adding 0 in the beginning doesn't change the value. Adding 0 in the end doesn't change the value if you have a decimal. If I have 12, then adding 0 makes it 120. I am not supposed to do that. I will fail as a teacher. Okay? But if I have a decimal, then I can play. Yeah? So, see, these are some of the basic tricks that we need to be aware of. Our job as a student or as somebody who's solving problems is to make sure that when I'm doing the calculation, I'm not changing the value. As long as I'm not changing the value and then doing the calculation, I'm not making a mistake. Yeah? So, Sriyanji, is that clear to you there? So,
I just see the zero next to the chip.
right. So that's what I'm saying. So yeah, 1.2, if I have a need to add 2 zeros, I will add 2 zeros without worrying about it. That's what I did. So now look at this, okay? So here, when I have this problem to solve, I will use the same technique and see if that is helping us. Okay? Did I start recording it?
No.
Yeah.
Oh.
Okay. So if I have to add these two numbers, wait, what will I do? I will not rush to solve it quickly. First thing is I have to put some thoughts around it and see what do I see here. And I'm only concerned about the number of digits I have after decimal, okay? So here, 3 plus 2, 5 digits. Here I have only 2 digits. That doesn't look fair. Let's make it fair first. Okay, here I have 1, 2, 3, 4, 5 digits after decimal. Here I have only 2 digits. Okay, let's ensure some parity. Now this looks like, okay. Here also I have 5 digits after decimal. Here also I have 5 digits after decimal. Both look from the same fruit family. Both are watermelons. Yeah. Alright, so now I can add them. Let's write it in a very clean way. Very clean way. Meaning you have enough space between the numbers so that we don't get confused. Okay? And then this one is 2.1500. See? It looks very, very familiar, very nice, very, what you call, very friendly. Yeah? If somebody says, add these two. Yeah?
Hello.
Better? Yeah? So the idea here is that whatever we do, our job is to make it look similar, easier, much more familiar, and easier to eyes. This looks easy to eyes. Right? Now if you see, that's why I was keeping enough space between the numbers. Imagine me writing this like and then putting 43. Which one to add with whom?
I know.
It gets a little
That's confusing.
stressful, right?
I do that. I can't read that.
Exactly. So that's what I'm saying. Let's always make a practice. Trust me, by God's grace, none of us have any issue with resources. Meaning if I use 2 pages instead of 1, we are okay. We can do that. Okay? And we are blessed to have that. So that's good. Now I will use my paper in a much cleaner way, keeping enough space between the numbers. And make sure that they look very aligned. By looking at this one, I know that okay, this 1 and 5 are to be added together. I'm not going to add this 5 with 2. There's no confusion here. Yeah. So when you write it neat and clean, your job becomes easy. Ahana, is it okay, beta? Yeah? Is everybody with me? Yeah? Okay.
Yes, sir.
Okay, good. So now, look at this. This problem that we were trying to solve, this doesn't look like a problem anymore. Yeah? 2 and 2, everybody, this is child's play. You guys are champion in this. There's nothing to worry. Did I do anything magical? No.
No.
I just kept it clean. I made sure that I'm not dealing with apples and bananas together. First I brought them into the same fruit family by adding the number of zeros and do this. Okay. Now I'll show you guys how do we play with the zeros. Okay, zeros look like zeros, which doesn't seem to have any value. This is an absolute zero. That's what people say, right? But zero has a lot of importance.
Hi.
No value. Lot of value. More value. Yeah. So we have to make sure that we use zeros in the right way. And that's what we'll do. Let's say somebody says 0.12 plus 395.1. Yeah. This problem has no big deal. It's easy problem, okay? Provided we don't mess it up. So first thing you will do is, okay, here I have cheap. As I said, we'll always count the number of digits after the decimal. Here I have 2 digits, here I have only 1 digit. Okay? So let's do one thing. Let's make sure that both have same number of digits. Since I can add as many zeros I want, if I have a decimal, I just added 1 for both have 2 digits after the decimal. Yeah? Now let me write it down as neatly as possible. Yeah? Now this one. So I will align the decimals. 1 and 2. and I have a 0 here. And as we know, adding 0 on the left, no problem, right? Nobody is stopping us from adding 2 zeros. See, this looks much more
Okay.
normal, easy to deal with, right? Deal with it. Yeah? Is everybody okay with that?
Yeah. Yeah.
Now, am I a good teacher or bad teacher? Bad teacher. Because I keep on complicating problems for you guys. And that's what I'll do. No, so see, bad teacher as in not as a bad teacher. Meaning, see, I can keep on teaching easy things and say, okay, see, we learn everything. What I will do is, I will teach the concepts in a very easy way and enable you guys to deal with tougher problems also. That is why I call myself a bad teacher. I'll give you a little difficult problem and make sure that you guys do that in a very easy way. Now let's do this. If I say 1 minus 0.125. Let's see who all can do this real quick. 1 minus 0.125. Yes, Shanvi.
Can you minus that?
I think so.
I'll do it.
Okay, Ahana, Kian, everybody is trying, right? I'm giving you a simple problem, okay? 1 minus 0.125. Meaning you're trying to subtract 0.125 from 1. Give it a try. If you go wrong, if you do it right, I'll be happy. If you go wrong, I'll be happier. Okay, let's see. Let's see what my baby is doing. Okay.
0.875.
Yep, very nice.
So I have the answer.
What is the answer?
I think the answer is 0.875.
Answer is perfectly fine, but never say 0.875 because after the decimal we don't treat that as a number. We read that as a 0.875. I will read this as 0.875. I will not say 0.875. Okay, it's not read that way. If I have 0.87, I will not say 0.87. Okay, I will say 0.87 because see these two numbers are very close actually. While 0.87 or 0.875 looks way too different, but they're not. They're very close. Okay, there's a very small difference. So after the decimal, whatever you have, you will read that as a number 0.875, not 875. Okay. Okay. Who is still working on it? Rudraksh, where is your? What is this? This is not a good sign. When you do this, right? This means I don't care. If you notice people say, okay, do you care about this? No, I don't. When you say I don't care, you will see that the shoulder goes up. So if you don't say anything and the shoulder goes up, it gives the same message that I don't care. Don't give that message. Okay. What did you do? Did you try something? Did you try scratching something on the notebook? Do it. Make my picture if you can't do anything else.
Why did you write 0.87 on the board?
I'm sorry, Rita?
Why did you write 0.87 on the board then?
Why would you do 0.87 before?
Yeah.
What is the question? I remember that one more time.
Why did you write 0.87 on the board?
Okay, why I was doing that was because when one of you told me that 0.875, I am saying that 0.875, we never read that as 875 because 0.875 and 0.87 are very close numbers. There is not much of a difference, okay? But when you read it as 0.87 versus 0.875, looks to be very different from each other, okay? There is a big gap between them, but there is not enough gap actually, okay? So that's why I was coming to that. Anybody who is working on it? Yep, Soita, tell me. Unmute yourself.
I'm working on it.
Oh, you're working on it. Don't work that hard. It's an easy one. Yes, Ved.
It's 0.875.
Okay. Okay. So whoever, Yaditi. Yaditi, tell me.
875.
875. Okay. Now, I will. Some of you who are still working on it, okay, just now pay attention to it, and Rudrakshu as well. Ahana, Rudra, Syanvi, everybody here, okay? Sohita as well. So, what did I say in the beginning? I said that I don't deal with apples and oranges together. I like apples and oranges both, but I don't deal with them together. You will never find me eating 2 apples and then 2 oranges in the same meal. I'll plan my meal in a way that when I'm eating apple, I'm eating only apple. When I'm eating bananas, I'm eating only bananas. From a math point of view. So now here I don't have decimal, but here I have a decimal number. Yeah. I want to first make them as decimals, both of them. So 1 and 1.0 are same. Yeah. You guys agree or you don't? Agree?
Agree.
Now I said okay fine. Now I have a decimal. So instead of 1 I can say 1.0. Okay. This is better. But still there is a difference which I want to fix. Here I have 1 digit after the decimal. Here I have 3 digits after the decimal. Rudraksh here. If you don't pay it, what happened? Anything falling? Okay. So that is because you stay stable and focus on math, not on the table. Okay?
How do you work?
Is that a problem that you want to fix right now? No, right? We have to focus on math only. Yeah. Focus on math. The table I can replace. Concept will not get replaced. Okay? Concept will remain with you forever. Now, coming back to this one. So I had 1 that was not looking, something that is easy to go with. So I said, okay, fine. This one is the actual number. This is a decimal. How about this? This is better. Both are decimal. This is a decimal number. This is a decimal number. Looks better. But there is still a difference. Here I have 1 digit after decimal. Here I have 3 digits after decimal. Now it's looking nice. Still apple oranges. But we know that if I have a decimal, I can add as many zeros I want. So here I have 3 digits after decimal, I added 3 zeros. Now they look similar, from similar family. Yeah. So I have now 1.000 and 0.125. So this one also have 3 digits, this one also have 3 digits after the decimal. Now I can deal with them. So 1.000. And here I have 0.125. Yeah. Now it's very easy to do. Correct? You have 0. You don't know how to subtract. Okay, you'll borrow. Keep on borrowing. You borrow 1 from this guy. This guy doesn't have anything. Okay, this guy borrows 1 from this guy. This guy also doesn't have anything. This guy borrows. So this guy is actually starting the borrowing business. So this guy borrowed 1 and got 10. So this guy has 10 now. And so he kept 9 with it, gave 1 to this guy. So this 10 got distributed this way. Now this guy has 10. So this guy says, okay, give me 1. So now this guy has 9 and this guy has 10. Okay? So now 10 minus 5 is 5, 9 minus 2 is 7, and 9 minus 1 is 8. And this one we already borrowed, so this is 0. So you have decimal, 0 minus 0 is 0. So this is how you guys got this value. What happens, Hiranvi? Is it making sense or not making sense?
Making sense.
Yeah. So the beauty of this problem lies in, or beauty of this solution lies in simplicity. How simple are we making it for ourselves? Ahana, is it clear to you, beta? Yeah? So is it clear to you? Okay. So you are there. There you joined just little late, but we are just doing fraction operations. Okay, so we looked at not fraction, decimal operations. So we did decimal addition, and we are doing decimal subtraction right now. Okay, and thankfully I have not taught anything so far. I was just telling that when you are dealing with decimals, you can always make it simple. Make sure that all the numbers that you are trying to add have similar number of digits after the decimal, and then you can add or subtract them. Yeah? Okay? Alright. So, we did decimal subtraction also. So tomorrow if somebody says subtract 22.05 minus 1.172, first thing you will do is, yeah, tell me the story.
Add a 0 to the end of the 5 to make it a number.
Yes, KR. Okay.
I will add a 0 to the 22.05 and add a
When you add a 0, then you have 3 digits here, 3 digits here, then your journey begins. Then after that it's a simple subtraction, correct?
yeah.
Okay. So far life was looking okay. Now let's make it complicated. For real. Let's do it.
Now are we going to do multiplication and division with this?
Yes, sir.
Don't make my phone do
We'll do multiplication and division. Are we ready for it?
Yeah.
Okay. 1.2 multiplied by 15. And when you're doing it, Rudraj, here, okay? If you have seen me, how do I do it? I always write stories, okay? So look at my storytelling skills. So I'll solve this for you, okay? You need to buy another. No, done? Okay. So see, look at this. I'm trying to do 1.2 into 15. And right now you can see it as well. Okay, so you would have got that as, okay, you multiplied it, right? Okay, so that is one way of doing it. I'm showing you another trick here. I'm coming there, but just give me 2 minutes, okay? I have this decimal and this is a natural number. Yesterday we learned I can always convert a decimal to fraction. 1.2, I will write it as 12. And then I remember, oh, I have to put a 1 for the decimal. And then I have a 15 here. Meaning it became 12 into 15 divided by 10. Now look at this. 12, I can write this as 4 into 3. 15, I can write this as 5 into 3. And what do I have here? 10. I can write this as 5 into 2. Yeah. So this calculation can become easier actually. So now that's for you. Yes, but I'm coming there. Just give me 10 seconds. Whatever I'm doing here, look at my story. From here, my first step I converted this to fraction. Then I'm breaking it down. Then I'm solving it. I'm literally telling you guys a story when I'm solving a problem. What happens, Shyanvi? Shyanvi is confused. Worried? Yes, Kian.
I have the answer, sir.
What is the answer?
The answer is 18.0, and I also know how to find that answer.
Okay.
simply do regular multiplication.
Uh-huh.
But then because now there's only one digit in like there's one digit for the decimal, then I would add a decimal point, one digit to left.
Okay. So hold it there. I'll come to. I don't know what the answer is, so I cannot say whether this is right or not. But hold your answer. I'll come to you. Anybody else who has got the answer? Yes, beta.
I got 18 because I multiplied 12 times 15.
Okay.
Well, and I got 180 and I
Divided by 10.
put my decimal
Yeah.
to the right.
Yes. Okay. Yes. Sohita, what is the answer?
My answer is 18.0.
18.0. Okay. Anybody else who is working on it? Ashar, did you do it, beta? Did you try multiplying this decimal with this number?
Those two?
Uh-huh.
Yeah.
Wait, how about you?
Let's see.
Working on it? Okay. Now, time to play. Time to play with math. Did anybody use tic-tac-toe or the method that we learned yesterday
No.
to convert fraction, decimal to fraction?
No, sir.
Okay.
Because there was no need to convert a decimal to a fraction. Now there's a need to use tic-tac-toe.
Okay. So let me tell you guys. One method is simple, like many of you tried. Okay? That is, multiply these two numbers. So 15 into 12 is 180. And then you have a decimal after one digit. So move from here. 18.0 is the answer. That is one method.
That's the method I used.
Okay. Now, that is when you guys are serious. When you guys are stressed out. When you are trying to solve math as a math. I always have a plan to find out fun element in math. Tic-tac-toe is my favorite because that reduces the burden on me. Though I remember the table of up to 20, still I believe, but I try to use smaller tables more often. Okay? So see, I'll tell you why. So one method is this, multiply these two numbers and then count this one. Okay? Let's say you had 15.0 times this, then you will multiply these two, that will get 150 into 12 will get you 1800, and then you have one digit here, so two digits, 1, 2, that will be the answer. That is how it works. So let me do it one more time. Let's say somebody says 1.32 multiplied by 1.41. Okay? Don't do it. I'll do it for you guys. Okay? If I have to do it, what will I do is 141, 132, multiplying it. 2 1 is 2, 2 4 is 8, 2 1 is 2. Cross 3 1 is 3, 3 4 is 12. 1 carry forward, 3 1 is 3 plus 1 4. Then 2 cross. 1 1 is 1, 1 4 is 4, 1 1 is 1. Add them together. 2, 8 plus 3 11, 2 plus 2 4 plus 1 5 plus 1 6, 4 plus 4 8, 1. 18,612. This is what I got. But I have to find out how many digits I have in my answer. 1 and 1, 2, 3 and 4. So you have to count all the digits in both the numbers and just add them together. So 1, 2 here, 4. So you start from here. 1 digit, 2 digit, 3 digit, 4 digit. That becomes your answer. In the most orthodox method.
Sir, I'm getting hot.
I'm sorry?
I'm getting hot.
Okay. So let me close this door and turn this on. 1 minute guys, okay? Just 1 minute. The kids have a complaint here. Alright. Anybody is feeling hard. And then you will feel better. Alright. So the teacher disappeared, isn't it? Because teacher was having fun. Can you guys see the board okay?
Yes, sir.
Okay? Alright. So, the kids here were feeling hot, so I had to find out a way for them to feel a little comfortable. So, yeah. So, what I was talking about was, if you have to multiply two decimal numbers, you multiply them without looking at the decimal, multiply them in the normal way, and then once you have the answer, you find out where to put the decimal, and that is by counting how many you have here and how many you have here. Put them together, this becomes 2 plus 2, 4. So you start from here, 1, 2, 3, 4. This is your answer. Okay? Now, this is the orthodox method. This is what everybody uses. Yeah?
Yes, sir.
Everybody is aware of it. Yeah? Now, what I'm saying is, there is another fun method that you can try as well, and that will reduce the burden on larger calculations. Okay? Now don't stare at the AC. Everything is settled now. Here. So I was saying 1.2 into 15. This was the question. Right?
Sir.
And as your teacher is always playful, he wants to play with it again. And what did I teach yesterday? Saying we can convert a decimal to a fraction. See, 1.2, 1.7, 1.9, what is that? If I say give me $10, it's easy to understand. If I say give me $10.3, you can find it out. I'm saying that's not easy, right? $10.30. But I'm saying if I say $10.35, not fun. So 35 cents. I know you guys know it, but I as I said, I'm always a mischievous person. If I say now give me $1.373, figure it out.
That's impossible because it only goes down to numbers.
Right. So what I'm trying to say here is, decimal is a good concept to learn, but a difficult mathematical calculation. So if I have an opportunity to knock off the decimal, I would do that in the first go. Now look at this. Yesterday we learned that if you have a decimal, we can convert that to fraction. What I can do, this 1.2, I can convert to 12. I will write this without looking at the decimal. Then I will put 1 for the decimal because I have one decimal, and then I have one digit, so 10. See this, the decimal converted to this fraction times 15. Now I am not done playing yet. I'm going to play more, and that is this 12. I can write this as 4 into 3 or 2 into 6. Let's say 2 into 6. 15 I can write this as 5 into 3. Yeah? Then I have 10. 10 I can write this as 2 into 5. Yeah? See, my game starts. This 5 and this 5 tic-tac-toe. This 2 and this 2 tic-tac-toe. What I'm left with?
18.
18. Is that answer matching with everybody's answer?
Yes, sir.
Who played more? Yeah? I want you guys to play as well. Because here, see, I'm not saying that what you guys did was wrong. What I'm saying is, when you're dealing with bigger calculations, the chances of making mistake is more. If you make it a simpler calculation, your chances of mistake is less. Does it make sense?
Yes, sir.
Ahana, what do you say, beta? Is it looking okay? Yeah? Shyamli, are you with me? Asher, Ved. See, I got a heart from Ved. Very nice. Okay, so it's not about me getting a heart from Ved. It's about when somebody clicks on this or this, not to disturb the class, but to express that, yeah, I liked it. When you express that, then I get the confidence that yes, kids have understood it, so we are going in the right direction. Yeah? Alright. So, I want you guys to do one more problem. Now this time, I am going to make your life interesting and difficult at the same time. 1.5 into 1.6 into 2.1 divided by, no, okay, let's multiply this one. Okay, let me not make it so difficult. Okay. Now we are trying to multiply 3 decimals. If you would have done the normal way, that would have been a little difficult task. What happened, guys? Okay, your eyes are having water. That's allergy. No, okay. No, I mean, I thought you are trying. Alright. So here we are trying to multiply 3 decimal numbers. And if you do it the normal way, it's a task. If you do it in a playful way, it's a fun. Do it. Let's see who all can do it real quick. Everybody got the question right? Let me write it in double font. 1.5 times 1.6 times 2.0. Can everybody see the question?
Yes, sir.
Not you on the screen. You guys are better off. Yep. Can everybody see the question? Okay? All right. Do it.
Still I have the answer.
You got the answer? I'll be there in a minute. Just give me 1 more minute. Okay? Are you guys getting cold air? Is it okay?
Yes, I'm confused with the problem.
You're confused about it? That's a good sign. That means you're fine. Okay. Okay. I come to that. It's okay. Yeah. What about you? Thinking doesn't help. Doing helps. Yes, Kian, what is the answer?
My answer is 48 point. Oh no, 4.8.
4.80. 4.80 is that right? Yes, Shamli.
Standing at Kian, but with another gear.
And say it one more time.
It's 4.8.
4.80. So you never say 4.80, you say 4.80. Okay. How about Ashar, Aditi, Ahana, Swahita, Mandeep? Where is my buddy? Mandeep has not even said a single word today. Are you with me, beta?
Sir, I have my answer, but it's in fraction form.
Okay, how much is that?
4800 out of 1000.
4800 by 1000. Okay, we'll come to that. Arab, you are 10 minutes early for your class. Please join after 10 minutes. Yep. Ashar, Aditi, Ved, Sahita. What is the answer? Shyami, you told me your answer anyways.
I have a question.
Okay.
So, are we going to be division and are we going to do division on this?
We will, if the time permits. We might not be able to do it today because we have only 10 more minutes. So,
Sir, I got 3.6.
in the next class, that's okay. Let me see. Okay, this, because this kind of calculation, you will see me do on the board again. See, if you look at the previous page, I am going step by step. So that if I go wrong, I would be able to go back to that step and figure out where I went wrong. From this problem, trust me, I can hardly make any head or tail out of it. Write the questions, do it step by step, that's the way to solve problem. Okay, now everybody who has done it or who did not do it, let's start playing together. As I say, I don't care about the answer, so I'm not caring about anybody's answer right now. Once I do this problem, then we all will validate. Okay? And when I say I don't care about the answer, the purpose is this. I want everybody to think that if somebody gives me the answer, oh yeah, that is the answer, I got the answer. No. Answer could be wrong also. You always trust yourself. Do the problem yourself and then validate anybody else's answer. It should not be okay. My best friend has given me the answer, so that is the answer. No. Do it yourself. Now 1.5 into 1.6 into 2.0. Everybody here. Naita, you also done. So here, first of all, as I said, dealing with natural numbers is okay. I know the tables of 1 to 20, but I don't know the table of 1.5. Okay? So I will not do this kind of calculation by myself. What I will do is, I'll first convert this decimal to fraction so that these numbers look better to me. So this becomes 15 divided by 1 for the decimal and then add 1 digit, so 1 0.
So my answer is 4.8.
Okay. Now everybody please watch me do it and then validate whatever you have done. Aradhya, are you with me, beta?
Yes.
Okay. So now I had 1.5 into 1.6 into 2.0. That's what we were trying to solve. All these decimal things I don't like much. I would rather convert it to natural numbers and then see what happens. So 1.5 I know I can convert into a fraction. It's a decimal, I can convert to a fraction. So it becomes 15 divided by 1 for the decimal and then I have 1 digit, so 1 0. Similarly, 1.6 becomes 16 by 10 and then 2.0 becomes 20 by 10. Now look at this. So what I have is 15 into 16 into 20, everything on the second floor and everything on the first floor. 10 into 10 into 10. We can do all this calculation, but we don't want to. Let's see if we have an opportunity to play. 15 I can write as 5 into 3. Yeah. 16 I can write as probably 2 into 8. 20 I can write as 5 into 4. Here 10 I can write this as 5 into 2. This 10 also I can write this as 5 into 2. This 10 also I can write as 5 into 2. Yeah. 1 5 1 5 tic tac toe. 1 5 1 5 tic tac toe. 1 2 1 2 tic tac toe. What I have here, 3 into 8 into 4. So whatever we have, let's write it down. We'll see. 3 into 8 into 4 divided by 2 into 2 into 5. Now look at this. This 4 I can write as 3 into 8 into 4 I can write as 2 into 2. Okay? And here I have 2 into 2 into 5. So 1 2 1 2 tic tac toe. Other 2 tic tac toe. What I have? 3 times 8 divided by 5. 3 times 8 is 24 divided by 5. 24 divided by 5. This now I cannot do any tic tac toe. 24 doesn't come in the table of 25. In the table of 5. Kids, stop texting, stop chatting. This is not a class for chatting. Okay? This is a class for doing math. No messages, no emojis unnecessarily being used. 24 by 5, that's what we are trying to find out. Okay, now either I can stop here or if I want to get an exact value, we'll do that. So 24 divided by 5. Now the next fun thing will start. Chicken and egg. Yep. We start from 5. 5 4 are 20, 5 5 is 25. So I cannot go to 5 5. 5 4 are 20 is what I have to settle with. And I get a 4. And this 4 is smaller than this, there's nothing to slide down. Chicken. I put the chicken, I get a 0 here. 1, I get a tie. 5 8s are 40. All done.
But still,
Yep.
but I feel like wouldn't it be, of course it's more fun to do it this way, but wouldn't it essentially be faster to just do it regularly rather than all this crossing out and breaking down individually?
Up to you guys. If you think that multiplying 15 and 16 and then 20 is faster, please do it. So I'm not forcing anything. I'm just saying find out what you enjoy, what you can do quickly. Okay? This question might be easy to do it by itself. There could be questions where this might make it faster. So it's always a whatever you guys feel comfortable, okay? I'm not here to say, okay, no. From today onwards, everybody uses tic-tac-toe. No, I'm not saying that. I'm giving you guys 2 ways to solve the same problem. Whatever you find more fun with, you can choose that. Whatever you can use for doing it faster, you can choose that. Yeah? So, again, I am a very flexible teacher when it comes to teaching something. I am giving you guys different ways to solve a problem. Any problem you pick up, there will be at least 3 to 4 ways to solve it. Okay? It's always based on what we are comfortable with. What I am comfortable with might not be comfortable for Rudraj. What Rudraj is comfortable with might not be the same for Ashara either. So everybody will have different ways to solve it. You always have to look at what works the best for you. What you enjoy the most. What you like doing. Where you are being more playful. Where you feel more comfortable. Where you think that your accuracy will be better. Yep. I'm here to just tell you guys different ways, different techniques, and you can always choose yours. Make sense? Have fun. See you guys next week.